Um, all right, again, this week we're going to do something a little bit different. We're going to do a hands-on exercise. We're going to do a live hands-on exercise during the webinar, and not a whole lot of folks in the webinar right now, but this is something that the people, I know there's been quite a few folks coming back and listening to the recorded versions of these. So if you're listening to the recorded version of this, then you can do the same thing we're going to do here. But this is how I would do, this is how I might approach using the CyberRange in the classroom, and I've done this workshop before with both with students and with teachers, and it's kind of an effective approach. This is just an example, right? So today we're going to talk about passwords and how passwords are represented on modern operating systems, and then how, you know, how somebody might approach trying to compromise somebody's passwords, and then we'll go on from there. So you should see my screen. I have the week 2 agenda up here, and there's an invitation code and there's a download site. So I don't know, you might take a couple of seconds to write those down. I'll come back to the slide, but if you're if the slide goes by too quickly, then you might not get it. So I'd just I'm going to pause for about 30 seconds, and I'm going to let you write these down or type them somewhere. Invitation codes, the two things in red. There's an invitation code and there's a URL. Okay, and again, I'm going to come back to this slide in a couple of minutes. First, let me start with overview, weekly workshop number 3, and the title of my slides are wrong, so I'm going to skip over the title slide. Okay, I'm going to revisit this slide. I've visited the same slide for the last couple of workshops. What are these workshops all about? Well, this is an attempt by us here at the Virginia CyberRange to provide you know, resources to educators, right? We're all about providing resources to educators, and I know that there are some folks teaching cybersecurity classes in the Commonwealth, or getting ready to teach cybersecurity classes, and you know, if you're doing that, more resources are always better. So we're going to cover in these workshops a range of topics. We started out the first couple of weeks talking about features of the Virginia CyberRange and did some, you know, demo and background and all that kind of stuff. Then last week we hit some more advanced features. So if you want to see how to move students around in your class, put them in teams. If you want to see the little bit of a description of different exercise environments, etc., then last week's workshop might be worth checking out. And again, this week we're going to do a hands-on exercise, a live hands-on exercise, and again, we'll see how this goes. For the workshops, I have a list of possible topics there, and you know, we're gonna start next week. We're gonna maybe move away from the range a little bit and just talk about some general cybersecurity topics. So I'll start talking about sort of an introduction to cybersecurity, what it is, why we should care about it, and then we will go into a variety of different topics: cryptography, networking, you know, authentication schemes, et cetera, as the semester progresses. And it's all down at the very bottom of the slide. If you would like to see a particular topic, then let us know what it is and we'll squeeze it in somewhere. Okay, so I like to start my classes. Anytime I'm teaching a class, I like to talk a little bit about recent news. This isn't super recent. This is from December of 2017, but this is news that was followed by several news organizations, and it's this worst 25 passwords of 2017, right? So this comes out every year. There's this review of bad passwords used, whatever year it is, and if you pay attention to security news, you usually see this, you know, end of the year, the end of the calendar year, or early part of the following calendar year. And what these are, what this news story does, and what similar news stories do, is they publish a list of passwords that have been compromised in over the last year, right? And where those come from? Well, there are places where malicious people trade in compromised accounts. So they'll go, there are websites, for example, one is called Pastebin. There are others on sort of this gray market where somebody will, some malicious person will find a trove of user accounts, and usually hashed passwords, so user accounts and not clear text passwords, but passwords that have been cryptographically hashed. And we'll talk in a minute a little bit about what that means. And what they'll do is they'll try to crack those passwords in a way that we're going to try to crack some passwords today. And then the ones that they crack, they'll publish online, and so that other malicious people can go get to them. And what security researchers will do is they'll go harvest all these different passwords, compromised accounts, usernames, passwords, and they'll publish this list of the most popular passwords from most used down to the least used. And so this particular list uses data from 5 million leaked passwords in North America and Europe over 2017. And we'll take a look at the list here. So I'm going to click on the link down at the bottom. Here's the list of bad passwords. And here's the full list of 2017's worst 25 passwords. Okay, it always starts with 1, 2, 3, 4, 5, 6. Then you get password with a capital P, 1, 2, 3, 4, 5, 6, 7, 8. These are pretty predictable, right? QWERTY. Why do we use QWERTY? Because that's the upper left-hand corner of the keyboard. Whoops. How about that? You get 1, 2, 3, 4, 5, 1 through 9. Let me in. These are not very creative. Monkey. This, I guess, is a new one this year. So this is up at like number 16 or so. Star Wars. 1, 2, 3, 1, 2, 3. So yeah, so this is a frequently published list of bad passwords. It always starts out kind of the same with this, these few at the top. And what this is telling us is that people are still using bad passwords, right? So today is all about why should we rid ourselves of that practice. Okay, so I'm going to move on from there. So today what we're going to do is I'm going to talk a little bit about passwords, and then we're going to do a hands-on password audit exercise. So what does password audit means? Well, we're going to crack passwords, but it depends on the context, right? So if you're a bad guy, you crack passwords. If you're a good guy, you audit passwords. And so like here at Virginia Tech, for example, I am the director of the Virginia Cyber Range, but I also am deputy director of IT security here on the campus. And we in the IT security office, we do occasional password audits, and what that means is we try to essentially try to crack some of our users' passwords. It's very context dependent, right? So somebody who has a particular system might come to us and say, "Hey, we want to see how good our users' passwords are on this system, so we want you to audit the passwords." And so we'll take their list of usernames and hashed passwords, and then we have somebody in the office who's very adept at this particular practice, and he will try to crack some of the passwords, and then he'll go back and say, hey, these are the bad passwords that we discovered. Here's the people with bad passwords. Another context we do this in is if we know that a system was compromised on campus, we will try to determine how the system was compromised, and one way to do that is to try to discover which accounts have bad passwords. So we can take the system, we can download the account information on the system, we can analyze the username password combinations, and we can determine who has the worst passwords. Generally, most people are going to have fairly good passwords, but there's going to be some bad password in the mix, and we can point to it and say, hey, one of these 3 accounts is likely to have been the culprit because they have really bad passwords. So password audit, right? We are examining our own systems to determine which ones might have bad passwords. So we're going to do a hands-on exercise, and if you want to participate, whoops, sorry about that. I put this slide next to the login page for the Virginia Cyber Range. So here I'm at console.virginiacyberrange.net, and I'm going to use this invitation code to create an account for myself in a course in the range that I created as an instructor for this particular workshop. And the invitation code is AHVCEGNKMDMG. Okay, I typed in the code, and it says you are registering for Virginia Cyber Range weekly workshops. To finish this registration, please confirm how you'd like to access the course. I'm going to use my Google credentials, and I will use my student account that I use when I'm a student. And boom, there we go. And that's how your students, if you don't want to send out course invitations for your class, that's how your students can get access to your course. And if you're not sure how to get that invitation code to hand out to your students, then take a look at last week's workshop. We went through that whole process, or look in our knowledge base. Knowledge base. So if you click on your account icon in the upper right hand corner, go to knowledge base, type in invitation codes in the search bar, you'll get to an article that describes how instructors can use invitation codes in their class. Okay, so anyway, here I am in a class, and Virginia Cyber Range weekly workshops is the class. So I'm going to click on that. There's only one environment in here. It's a Kali Linux virtual machine, and I'm not going to try to join this thing yet because it's still being provisioned, right? And this thing is going to be provisioned for the next 10 minutes or so. And that's great because I'm going to spend a few minutes talking about passwords, and then by the time we come back to this virtual machine, it should be ready to go. There's also a hands-on exercise that you can use that is a Word document that is available in the Virginia Cyber Range courseware repository. I provide it here from a different source, and I provide tiny URL access to it. So I'm going to go to a new tab, and if I type in https vacker.io/password_lab, that's going to download a Word document that is this password exercise. And we're going to get back to the Word document here in a few minutes. So I'm going to sort of move it out of the way. All right, so hopefully you wrote down the URL and the invitation code. And so now I'm going to dive into a discussion of passwords and password audits. And these slides are available in the courseware repository. So if you go to the courseware repository, go to the Cyber Basics content, you can just go and Google in the courseware repository for Cyber Basics, and then look for the I think the module it's under is like hacking, and there's this password audit lesson in there, and it's got brief lesson plan and then these slides. And so these slides are straight out of the courseware repository. These are available to anybody who has a courseware account in the range. Okay, hands-on with password audits. Here's how I would describe this approach to password audits to students. Some learning objectives. So we're going to talk about how passwords are stored on a modern operating system, describe how attacks on user password hashes are carried out, right? So how does a hacker approach, or how does a password auditor approach trying to crack passwords? We're going to apply some tools to attack password hash files. And then we're going to describe why password complexity is important, and I think it's going to be obvious once we do this hands-on thing. I should mention that I'm not looking at the chat. I mean, I see there's some chats, but my helper isn't here today, so I'm going to ignore the chats until the very end. So first of all, how are passwords stored on a modern operating system? It's kind of this is helpful to understand when you start thinking about how you might approach cracking passwords. Passwords are not encrypted. So that's important to understand. Passwords are not, some people think of like, okay, I have a word, in the old days, a system might store your password in what we would call plain text. So if I had a username, my username was John Smith, and my password was password123. In the very early days of operating systems, that password might be stored just in plain text on the system that I'm trying to log into, and so when I try to log in, the system simply compares the password that I type in to that stored plain text password. If it's a match, it lets me in, okay? That's why would you not want to do that? Well, the reason you'd not want to do that is because if somebody maliciously gains access to that password file, now they have everybody's password, and that's bad. And nowadays, we all have multiple accounts in different locations. You might have if you use a password manager, you'll see that you probably have 100 or more different accounts that you have passwords for. Just on Virginia Tech alone, I have probably a dozen different systems for which I have to have a password. you know, you have your bank, you have your multiple email addresses, you have your school, you have all these logins. Each one of them has a password. If you use the same password for all of them, you're doing the wrong thing, because if somebody cracks the password for any one of those, now they have the password across all these systems. And smart hackers will absolutely use that against you, right? If they find a password dump somewhere where they see your email address and a password associated with it, then they'll try that username password combination on all kinds of different systems. And if you use the same password in multiple systems, that's a problem. And now your password is only as good as the weakest system, which could be really weak. Like somebody could actually store your password in plain text. Extremely bad practice. It probably still happens in some places. And again, in the early days of the internet, that's how passwords were often stored. Now we don't do that anymore. You know, you can imagine that you want to use some representation of the password that's hard for a bad guy to create. And so you might think it's encrypted. You know, we know that there are these different encryption technologies out there. You take a password, you run it through, you know, whatever RSA encryption, and you get some result. And now I could, you know, that's one way that you could make a password so it's not readable. The problem with that is that if you encrypt a password, then that password is reversible. So somebody could decrypt it. If it's encrypted, it could be decrypted. And that's bad. We don't want somebody to be able to decrypt the password, because then what they could do is they could get the key with which that system encrypts all of the passwords, and then they could decrypt all of the passwords. And we don't want that to happen. Another thing that we don't like about encrypting passwords is if you encrypt the password using a standard symmetric encryption algorithm like RSA, now those resulting passwords are all of different lengths. And that's bad for if I'm programming a system and I want to use, you know, have standard sizes of my password representations, then using encryption is just not a good technique. So what we do instead is we use hashes. We hash the passwords, and a hash is a particular kind of a cryptographic function that we call a one-way function. And I mentioned this on the slide here, right? A hash is one way. It cannot be reversed. Okay, so that's an interesting property of a hash, right? I can take a value, I can take the password, however long it is, and I can run it through a hashing algorithm, and that hashing algorithm is going to turn that password into a particular representation of the password. It's going to be a fixed length, so it's always going to be the same length, even if your password is longer than that fixed length resulting hash. If you hash something with the same hashing algorithm, you're always going to get the same fixed length output. And if you hash the same word using the same hashing algorithm, the output is always going to be the same. Okay, so that's important. If I hash the same value using the same hashing algorithm, the output's always going to be the same. What I cannot do is I cannot, quote unquote, decrypt that hash. So a hash is a one-way function. If you want to learn more about hashes, there's all kinds of great stuff on Wikipedia about hashing algorithms and how they work. It's really interesting stuff. I'm not going to get into the details, but the important things to remember are, first of all, the hash is a one-way function. Second of all, it gives a fixed length output, and we're going to see that here in a minute. So now think of how you might use, think of the algorithm that you might use to let somebody log into a system. You accept their username and you accept their password, and then you take your password, you take the password that I type in and you hash the password. And so now instead of comparing the plain text password to the plain text version, stored version of the password, you take the hash value and you compare the hash value of the password. Remember, you accept their password and you run it through the hashing algorithm, and then you compare that hashed password to what you have stored in your database. And if those values match, then you let the person in. Okay, so think about what that means from a security standpoint. If a malicious person gets access to that password, that database that contains the username and hashed passwords, it's essentially useless to the hacker because they have the username, but the password is hashed already. And so if they were to go to that system and type in that username and then type in that hashed password would be hashed again, and the output would be different. And so now the hashed hash is not going to match the hash, and the user can't get access to the system. The hacker can't get access to the system. It's also the case that the hashed, we said that this is not reversible, right? So the hacker has this hashed representation of the password, but they can't turn it back into the original password. So hopefully that makes sense. If anybody has any questions about it, then contact me after the fact. But that's just how it works. And if that was unclear, then I'd go back and listen to this again because it might be confusing the first time you hear it. Okay, so I have another slide here, and I don't know what it says. Okay, so how do you crack a password? So let's go back one and think about this. This is a question I like to ask students at this point before I go to the next slide. I say, okay, you're a hacker, right? You break into a system and you have their password database, which is list of usernames, list of hashed passwords. How are you going to turn those hashed values back into usable passwords, right? The hacker's objective is to get the password. The password hash could help them, but it doesn't get them to their ultimate goal. So how, this is what I would ask the class, right? How are you going to do that? So does anybody want to type into a chat here? I'll look at the chat here for about 20 seconds and I'll say, what would you do if you're the hacker? How are you going to crack the passwords? All right, I'm not going to wait any longer. I want to move on here. Oh, rainbow tables. Yeah, rainbow tables. Someday we'll talk about rainbow tables tweaks, but not today. So here's what you do. You're the hacker. You want to turn those hashes back into passwords. What you do is you start taking words in a dictionary and you hash each one of those words, and then you hash a sequence of characters, and then the hashing algorithms are well known, right? The hashing algorithm is not kept secret. I should have mentioned that earlier. Hashing algorithm is well known. It's not kept secret. There's some standard hashing algorithms, MD5. I'm not going to talk about the list, but there's a list of hashing algorithms, and they're published. They're well known. It all goes back to a thing called Kirchhoff's principle, which says you can't keep the encryption algorithm secret because somebody's going to be smart and they're going to discover flaws in it that you didn't discover. So you got to make it public so smart people can find the flaws, and then you can create a better algorithm. So you're the bad guy. You take a list of words, you hash each word, and you see if it matches hashes in the list of hashed passwords. And if you get a match, then you know you found that person's password, right? So that's how you do it. The thing about that approach is it's time consuming, right? So if you have a bad password, you might find those bad passwords really quickly because you use a dictionary that has things that might be bad passwords, or it might just be an English word dictionary. And if somebody uses a dictionary, if somebody uses an English word as their password, then those things are going to be discovered quickly. So I'll start at the top of the slide here. Password crackers don't try to decrypt passwords. Remember, passwords are hashed, so they can't be reversed. Instead, values are hashed using known algorithm until a hash matches a hash matches the stored hash value, is what that should say. When the hashes match, you have the password, or a password that will work, right? I won't talk about hash collisions, but that's a thing that could cause two different words to hash to the same thing, and either one of those things would work. So now it turns out that in Linux, this data is account data is stored in two different files. One is etc password /etc /password, and the other one is etc shadow /etc /shadow. And here in a minute, we're going to log into our Virginia Cyber Range VM, and we're going to take a look at that. First, I'm going to go to the next slide, and I'm going to say salts. I'm not going to get into too much depth of this notion of salts. This would, if I had a class that was an hour and a half long and I wanted to spend an hour talking about passwords and then 20 minutes or so doing the hands-on exercise, I would talk to students about salts. But I'll be very brief here. What a salt does is that a salt prevents me from just creating it prevents me from just pre-computing the list of all the passwords, is what a salt does. So a salt is this extra value that we sprinkle into the password to make it hash differently than if we just hash the word itself. And I'll show you the salts when we get to the password file, but I'm not going to go into very much more depth than that because it's not a lot of time to discuss it. So assault is a thing that precludes a hacker from just pre-computing hashes to all the words in the dictionary and then referring to that list. That would be a lot quicker than doing it, than having to hash each thing on the fly. But salts make it more difficult to do that. And then you have to use a thing called rainbow tables, which is what Tweaks put in the chat room here. And again, I'm not going to talk about that today. Okay, so next. All right, so we're going to use a particular tool to crack passwords. It's called John the Ripper. It's a tool that's been around for a long time, 20 years maybe, and it's probably the most widely used password cracker that is out there. It's an open source piece of software. It's widely used in the InfoSec community. It's free for it's free for the basic license. You can pay for the pro version, and people who are, the people who pay for the pro version, somebody who's a hacker is probably going to use the free version and they're going to tune it themselves. People are going to pay for the pro version are people who are responsible for securing like your bank's network, right? And they want to do password audits, and they'll pay for the pro version of John the Ripper, and they'll have some additional features, and it'll be more efficient, and et cetera. You can download John the Ripper from the web, and I don't remember what the website is, but if you Google, John the Ripper download, you'll find it. It's highly tunable, so you can tune it to the specific architecture that you're going to use of the computer that you're going to use to do the password cracking, and you can tune it and then compile it yourself. And so people who are doing this, what tuning does is it makes it so you can crack more passwords quicker. You can hash more values quicker, and that gets you further down the list of potentially bad passwords. So tuning it is all about making it more efficient, be able to crack more passwords quicker. By default, John starts with a password dictionary, and that password dictionary is stored in this location, user share John password.list, and we'll take a look at that in just a second. Okay, so this is the tool that we're going to use today. Again, very popular tool, widely used. Okay, so this is the hands-on part. So now what I'm going to do is I'm going to pause. What I would normally do here in the classroom is I would stop and ask if anybody has any questions. I'm not going to do that right now, but what I'm going to do is I'm going to go back to my Virginia Cyber Range account, and remember I previously used this invitation code to join this course, and did anybody else do that? Let me look. Oh, I can't see as a student. Never mind. I can't see. A couple of folks. Okay, so that's good. So it's ready, so I'm going to click the play button. And hey, there we go. My thing is provisioned, ready to go. So this is something that you can do, like when we do teach workshops, this is what we do at the beginning of the workshop. We have people join a class using an invitation code, and then we talk for a while, and then the students can come back in and start using it. And I'm gonna make this a little bit easier to see. Okay, so let me go back to my John the Ripper slides here. So by default, John starts with a password dictionary stored in user share John password.list. I'm just gonna, let's just take a look at that list. User share John password.list. And hey, what do you know? Some of these passwords look familiar, right? There's some discussion up at the top, tells where this list of passwords came from. You can get better lists than this. This is just the default list that John the Ripper comes with. But if you were to go out on the interwebs and do some Googling, you could find some probably better, more recently curated password lists. But look, you see the same stuff that we saw in that news story, right? 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, password 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the password, so John the Ripper's password list is not a list of dictionary words. I mean, there are a lot of dictionary words in it, but it starts with a list of bad passwords that have been culled off of different system compromises, and that makes sense, right? Don't start with dictionary words. Start with what people use that are bad passwords, and so that might be sort of a self-fulfilling prophecy, right? If we're testing against known bad passwords, then what are the most likely passwords that we're going to crack, ones that have previously been known as bad passwords. So that list of the 25 worst passwords in 2017 might be a little bit misleading because we're finding things because we're looking for those specific things. A little bit of a metaphysical discussion there, but I won't get into the philosophy. So here's this bad password list. We see things on there: QWERTY, Mickey. I don't see Star Wars on here. 1, 2, 3, ABC. Oh, A1, B2, C3. That's interesting. But we got the old ABC 1, 2, 3. And if you go down a little further, you start getting into bad words and stuff like that. Some educators, some teachers I know that use this, they'll cull out the bad words. I don't know. I think your students have seen all the bad words before, but do what you need to do for your class. That's the list of passwords that John the Ripper is going to use as it does this password cracking thing. And so now what I'm going to do is we mentioned earlier that account information is stored in a couple of files, and so I'm going to take a look at this file called Etsy password. And what do you think Etsy password has in it? Well, you'd think it has passwords, but it doesn't. Used to, not anymore. So here we are, Etsy password. And there's stuff going on here. Okay, so I'm going to try to get my terminal window so you can see the bottom of it. I may have made it too big. Let's see if I can make it a little smaller. Okay, here we go. So Etsy password has account names. Most of these are not accounts that you could actually log into, but you see down at the bottom of the list are student. Student is a loginable account. It has this /bin/bash is the shell that it uses. VACR /bin/bash, that's a system, that's a password that you use to log in. The ones that say things like user sbin no login, those are accounts that won't have passwords associated with them because they're used for some process on the system, but they're not accounts that you could actually log into. So Etsy password stores some account information. The place where the hashed passwords are stored is in a file called Etsy Shadow. And I try to look at Etsy Shadow and the system won't let me look at Etsy Shadow. Why is that? Because I'm not a user that has permission to see that file, right? So I'm logged in here as a user. I have low permissions. I can tell by my $ prompt. And so how do I make myself a root user? Maybe I'll go back to my, I'm pulling up my, on the right side, I've pulled up my Word document that has the password exercise. And first thing we have to do is make sure we are the root user. Make sure we have permission to look at things like Etsy Shadow. So I'm going to do this thing where I say super user do switch user, and I'm going to make sure it uses the environment that I want. If I don't give a username, it's going to make me root. So now I have a $ prompt. Now I'm the root user, and now I can take a look at Etsy Shadow, and I see a bunch of usernames. And again, most of these are you're not able to log into them, so they've got a star for the password. That's, so this file is stored in a very specific way. You have the username, then you have colon, then you have the hashed password, colon, then you have the account number, colon, and then some other stuff that I don't need to get into. But so there's always a username called, I'm on a Linux system, right? There's always going to be a username who's the root user. And this is the password hash. It goes from this colon to this next colon. Okay, so here's the root password. And I mentioned salts earlier. The value between these two $ at the beginning is the salt. And each different hashed password you'll see has a different salt. And remember, the salt is this random value that's sprinkled onto the password before it's hashed to make it more difficult for somebody to create a dictionary. Because if somebody created a dictionary with all the possible salts, the dictionary would be larger than could be actually usable. So let me go down to the bottom of this file, and looking at about 20 minutes left, so I'm going to move on to start doing some password cracking. The other password I see here that is a loginable password is the student account. So student, this is the account you should have logged into the system with, and here is the hashed password, right? And if you were to count the number of characters, you'd see that the length of this whole thing, the length of this, and the length of this are the same. Remember, we said that a hash results in a fixed length output. And the $6 at the beginning here, this specifies the hashing algorithm that was used to hash these particular passwords. I think in this case it's SHA-256 maybe. And then you have the password salt, and you notice that this password salt is different than this password salt because it's pseudo-random. Okay, so we've looked at the password file. So next thing we're going to do is I have the hands-on exercise on the right side of my screen here, and you know, the way I really like to do this in class is it's best if you have two screens. You know, it's rarely the case, but when I have the luxury of having two screens, what I usually do is I push slides to one screen, and I push the terminal window, you know, my Kali Linux VM to the other screen. Makes it really easy to see for everybody. Usually I have to do something like this, right, where I make my window smaller on the left side of the screen and I put up the commands on the right side. So this might be a little bit hard to see for you playing at home, but first thing I'm going to do is I'm going to create a couple of users. So I'm going to create a user, John Smith. Okay, there's a new user account I'm creating on the system. User add John Smith, and I'm root, so I can do that. And then I'm going to set a password for John Smith. So I'm going to say password John Smith. Now it's going to ask me for a password, and I'm going to put in a bad password. 1, 2, 3, 4, 5. Enter. You won't see these characters as you type them on the passwords on the password prompt, right? 1, 2, 3, 4, 5. You don't even see asterisks. You just don't get anything. But I just created that password, and it's 1, 2, 3, 4, 5. Okay, so now I'm going to create another user. User add Jane Doe. Password Jane Doe. It says enter a new Unix password. Now I'm going to create a good password. So I say here, non-dictionary word with numbers, special characters, etc. So I'm just going to put in a password, a passphrase that I know I'm going to remember, passwords are cool. Enter, passwords are cool. Okay, so now I used a passphrase in that case, a long string of characters, and I threw in a couple of capitals just to make it a little bit more difficult. I think that's a good enough password that I'm not going to be able to crack it in the short amount of time that I'm going to do this little exercise. Okay, so so I've done all this, right? I created 2 accounts, John Smith, Jane Doe, and I set their passwords. And so now I'm going to take a look at my let's see, shadow file, and I'm going to look at the very end of it, and let's see how this guy changed. Okay, so this is an interesting thing to point out to students. Before we could see the root account with the hash passwords. We have the student account. Here's the student account's hashed password. It goes from here, from the first colon to the second colon. And here is John Smith, right? This is an account that I just created. And then I created a password for John Smith. And here's the password. It goes from the first colon to the second colon. Okay, and that's, if you start counting characters, you'll see that it's the same length as this hashed password, right? Because remember, hashes give you a fixed length output. You also notice that the salts are different, pseudo-random. But if you took that same password, 1, 2, 3, 4, 5, that I used for John Smith, you append this salt to it and you hash it using SHA-256 hashing algorithm, you're always going to get this result. And that's how the system allows you access. It does that very thing, and if the hashes match, then you're good to go. Same with Jane Doe. She has a password now. You can see the whole password is here, or the hashed version of the password. It's hashed using this specific hashing algorithm. Here's the salt that was used when it was hashed, and here's the actual hash value. That's the output. So if you take whatever password I typed in, passwords are cool, you append this pseudo-random string to it, hash it, you get this. So those are the password representations on my system. Next thing I want to do is I'm going to just make a copy of that Etsy shadow file, and I'm going to store it in the current directory in a file called pass.txt. So now I'm down here. So I'm going to copy Etsy shadow to pass.txt. Boom. All right, so now I can cat pass.txt, and here I have the same stuff, right? The only reason I do that is I'm a little bit hinky about messing with the actual shadow file, because if you break it, then you can't log into your system anymore. If somebody was if some root user was to delete this file, you wouldn't be able to get back into your system anymore. So I'm not going to operate on, I mean, a copy of it, and I'm going to operate on the copy of it. Okay, so now I'm going to run John the Ripper against that file. And let's see what result we get, and then we'll talk about the results. I'm going to run John against pass.txt. And really quickly get some interesting output. Okay, so it's actually the $6 SHA-512 is the hashing algorithm that's used. SHA-512, that's a specific hashing algorithm that results in 512 bytes of output. So here's the format of the output. Up at the top here is just describing what it's doing, right? So created this directory called /root/.john. I'll talk about that in just a second. It found some passwords that are using this specific password algorithm. So it's using this particular format to attempt to crack those passwords. It loaded 4 passwords with 4 different salts, okay? 4 passwords with 4 different salts, and those we looked at, right? It's the root, student, John Doe, and Jane Smith, or John Smith and Jane Doe, whatever they were. I don't remember. Oh, John Smith and Jane Doe, yeah. So the output here is when the system discovers and quote unquote cracks a password. Remember, what it's trying to do is it's taking words out of that dictionary list, and it's appending the salt, hashing them, and seeing if the result is the same as what's stored. We see that the output here is you get a password, and so you get the password and you get the account against which that password is used. Okay, so remember that when you log in as student to this Kali Linux system, the password for that is student. How do you know that? Well, if I go back to my description of the Linux environment, the login credentials for this virtual machine are student. So it discovered the student password right away, and then turns out that the root password is also student. It's not a very good root password now. Try to ignore my phone here. And then I'll point out that here's John Smith, right? So we created this user, John Smith. We gave him a bad password, and we cracked that bad password really quickly. Why was it so quick to crack? Because it's at the very top of that dictionary, right? So we know it's a bad password. We know it's going to get cracked quickly. This thing is continuing to chug along on Jane Smith's password, and it's going to continue to chug along until I tell it to quit. And what it'll do is it'll go through that entire dictionary, that whole John the Ripper dictionary. I don't know how many words are in it, but a lot of words. It'll try all of those, and then it will do this thing where it has this hybrid cycle where it goes through and it takes like it replaces the O's with zeros and replaces the A's with @ symbols. You know, the things that clever things that people do to make their password more complicated. You know, the hackers who are trying to crack your password, they're just as clever as you are, maybe more clever. So they know that people are going to do things like replace the A with an @ symbol and replace the O with a 0 and append the year and then an exclamation point onto the end of the password. I mean, that's like standard stuff that people do. So it's going to go through all that, and then what it's going to do is it's going to start this brute force cycle. So it's basically going to start with an A all by itself, then AA, or A, then B, then C, then D, then through the whole alphabet, through all the numbers, through all the special characters. Then it's going to try A, B, AC, AD, yada, 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 and it's going to do this brute force thing basically forever until the end of the universe, or until you hit Control C, which I'm going to do now. So I hit Control C, and I see that I crack, my results don't change, right? I crack the student password, I crack the root password, and I crack John Smith's password. And there are some files stored in, remember up here it says create a directory /root.john. So if I cd into root.john, there are some files here. There's john.log, john.pot, and john.rec. And if we just take a quick look at some of these, whoops, john.rec. John.rec is keeping track of, what is this keeping track of? It's just some details on this particular password cracking attempt. It's got, it's going against the file pass.txt. It sees that the format is SHA-256, et cetera, et cetera. If I cat john.pot, john.pot is the passwords that were cracked. So here is a hashed representation of a password, and here's what that password was, student. Here's another hashed representation of a password. This is also hashed to student. Why are these hashes different? Well, because they each used a different salt. And then the last one here, this must be John Smith's password. Here's the hash representation, and then here's the password itself. So it keeps a record, and then if I was to run John again against that same file, it's not going to try to crack these again because it already knows the answer. And then if I look at john.log, so john.log is like keeping track of where it is in the sequence of cracking the password, and it does that because if you were to if you ran John the Ripper against this huge password file, maybe you let it run for a couple of hours, and then the power went out for a few seconds and your computer crashed, and then you started your computer up again. Well, you don't want to go back and start from scratch cracking passwords again, start from the very beginning. That would, you have to wait, whatever, 2 hours to get to the point where you already were. So John uses these files to remember where it left off, and it will start again where it left off instead of starting from the beginning, essentially. And so I could restart this password cracking attempt. In fact, if I did it now, I'd have to go back to where I was, and then I'd have to say John pass.txt, and it's gonna, this tells me, it's starting where it left off instead of starting over from scratch. And if you hit space, you get some information about sort of where it is in the process. Okay, so that's that is password cracking, and I think this is this particular exercise, again, you can do this with all kinds of different hands-on exercises. This was just an example of how you might do this in class. This particular exercise, I think, is a good one because, I mean, you sort of describe some of the theory behind how the password is stored and how somebody might approach compromising the password. And then we create these accounts, one with a bad password, one with a good password. And, I think that's useful for students to see this because, we're often told, hey, don't use bad passwords, do special characters, do uppercase, lowercase, etc. But nobody ever really says why, right? And for me, the important part is the why. The why is because of the approach that has to be taken to do this password cracking thing. And the more complex your password is, the less likely it is for a hacker to actually try that specific sequence of characters when they're going through this password hashing drill to try to discover what your bad password is. Okay, and I'm going to stop there and see if anybody has any comments or questions. I think I'm pretty much at the end. Okay, so if you, I'm not going to do this, but there's part 2 to this exercise, so it's kind of fun if you want to dive in and crack some more passwords, basically. So we have a password file that's stored that you can download, and then you can this talks about using different password files and how you do that. And so there's a part 2 to this exercise if folks are interested. Okay, questions? Anybody have any questions? All right, awesome. So I'm gonna stop the recording, and then this recording, of course, will be saved, and it will be posted to our virginiacyberrange.org website soon, hopefully in the next couple of days, so people can come back to it later. So thanks for joining us today, and we look forward to seeing folks next week. So thanks.